Hello, my name is Eric Peterson, and I'd like to welcome you to another discussion about Avacia's KubeSlice technology. Today we'll be talking about a use case of KubeSlice that we call disconnected edge. So in this case, what we're calling disconnected edge is when you have a retail site where you have ongoing transactions and you want to ensure that those transactions are able to continue even if that retail site should lose connectivity to the cloud. You can have a configuration like this where what you see on the left here is a couple edge sites that are configured up with their own local application for some kind of, say, point of sale transactions or things like that. Storage goes into a local database, and then ultimately is pushed back to some centralized database that's being maintained in the cloud. Each of these edge sites is likely behind a firewall, and each of them would have their own sets of data, which again is being aggregated up in some central location. The idea is that if one of these sites should lose connectivity, the local transaction should be able to continue. Whatever happens should be restored locally, updates continue, and eventually, when that problem clears, connectivity is restored and everything would synchronize again with the backend database. And then, of course, transactions in other unaffected edges should be able to continue unaffected. So we have a brief demo to sort of demonstrate this. We've actually, our demo is actually a little bit simpler. In this case, we just have the two sites, one edge site and one cloud site. For the sake of the demo, both edge and cloud are being done in Google Cloud, GCP. And we'll fail the connectivity and prove that as we update this database, transactions continue, and ultimately resynchronize once connectivity is restored. So let's jump out of that and take a quick look at the services. First off, in the Avacia dashboard, you can see our two sites. We have one in Google US East and one in Google US Central. And if we take a look, we have created a single slice. In this case, we're calling it Postgres slice. Excuse me while I relog in. So Postgres slice, we have our two clusters, each of which has a gateway communicating with each other. And we can see the services that are available in each of these clusters. Primary 0 and Standby Primary 0 are the two database instances. And we have just an application that can add and remove data within the databases, just so that we can show the transactions. These are all present on the Postgres namespace. And again, it's the Postgres namespace itself that is represented by the slice. So now let's jump out of that and take a look at the actual transactions here, or the way this looks inside of the cluster. So let's first take a quick look at the namespaces available in these two clusters. Here on the retail edge, as you can see, we have our Postgres namespace and we have the KubeSlice infrastructure namespace. And the same is true if we look at our core side. Again, we have these two namespaces that are providing that service. To take a look at the actual implementation of the slice, let's just do a quick breakdown of, sorry, let me get that right. Kind of a long command, so I'm just pasting it in. So if you describe the slice, this is showing us what slices are present in KubeSlice, and right now we have a single slice called PostgreSlice. And looking at the retail edge location, we have two applications that are present. One, this is our Postgres database, and this is, again, the test application that can interact with it. And what you see here, there are the addresses of these services within the Kubernetes pods, but there's also the addresses of those services on the service mesh overlay. And it's a service mesh overlay that interconnects the two clusters together via the slice. If we actually do the same thing now and take a look at the core side, what we'll see here is that, again, we have the same services. We have the database, and we have the test tool. And again, in this case, the database is on the slice, and it has its pod address as well as its slice overlay address. In this case, we've actually configured the test tool only on the pod. So it can interact with the local database, but it actually can't interact with the remote side. Now, a key element of KubeSlice is the fact that it interconnects services from one cluster to another, basically making it possible for an application running in one cluster space to communicate directly with applications in remote clusters. It does this by exporting services and then importing them into the clusters. So in this case, we have advertised the Postgres service into both clusters, and as you can see, this is the address that it's reachable at. This address is part of the NSM overlay, so it's only reachable via the slice. And the same thing has been imported into both clusters. When we take a look at the other cluster, we'll see the same thing. So again, this service is reachable at the same address in both clusters, and they can both reach it. Finally, just to sort of illustrate what KubeSlice is doing here, let's take a look at the KubeSlice namespace itself. Oops. Here we have all of the pods that are present in the retail edge KubeSlice namespace. Key things to point out, here we have a gateway pod. This is what's implementing the tunnel that interconnects these two clusters together, as well as a collection of other services that are providing the KubeSlice management oversight. So to see how this all works, let's go and take a look at the applications. So here we have our database interaction tool, and as you can see, there are currently 1,800 entries in this particular database. So say we add another 100. We'll add them. It says they were successful. And if we refresh this, we can see now we have 1,900. Great. And if we go and look at the other side, and we refresh that, it also has 1,900. So right now, connectivity is present between the clusters, and all of the transactions are synchronizing. Now, to cause that communication outage that I mentioned earlier, for the sake of the demo, what we'll do is we'll just go into Google and we'll break the firewall that's allowing connectivity between the clusters. I'm just going to disable that. And now we'll go back and here we are on the retail edge again. We'll add another 100 transactions. And we'll check, and sure enough, now we're up to 2,000. But if we go and look at the cloud and refresh that, it's still at 1,900. So it's not able to synchronize those transactions right now. We can do the same thing again. I'll just add a few more. Again, up to 2,100 here. This side, however, is not able to synchronize. And if we go back and now we re-enable that firewall, as soon as that's finished updating, there we go. Now we'll go back and give this a minute to synchronize. As communication is reestablished, the database has to have a chance to resynchronize things. So we'll just give that a minute. Again, if we go back to the picture, what we're doing here is we're restoring this connection. And so now these databases can talk, and transactions that were recorded on the retail edge are now able to be pushed back to the cloud. I'll check that again, and there we go. Now everything is back and synchronized. And again, we should be back in the state where if we add more transactions, everything is immediately pushed back up to the cloud. And there you have it. KubeSlice is providing all the infrastructure to establish this tunnel, to associate a set of services with the tunnel, and be able to interconnect clusters in an easy way so that from an application perspective, everything's reachable. And all the transactions can occur as needed by those applications at the appropriate times. So that's it for today. Thank you for listening.